Yeah, hello guys. Good morning, and I hope everyone is doing good. Um, we are bringing to you another tutorial, and I think the last time we ended on, I think we ended on encapsulation, and that was the last thing that we were supposed to treat under the concept of object-oriented programming. So we came about to look at the concepts that are related to every object-oriented programming language, including Java. So we talked about the four concepts, which is I think inheritance, abstraction, encapsulation, and then polymorphism. We talked about all this. In today's session, as I've reminded you in the other video, we'll be looking at data structures. And let's get into defining what data structures are. It's not really anything huge, but when you start defining it, you get to understand what a data structure is. So first, what is a data structure? So a data structure in computer science is a data structure is a data organization, management, and storage format that is usually chosen for efficient access to data. So mostly in our day-to-day life, when we are dealing with computers, we would want to store data in a format that we can easily find, or we can easily retrieve, or we can easily search for values in. And that is why we choose data structures, right? Data structures are simply a way of organizing, managing, and storing our data in a format that we prefer, right? So an example could be an Excel sheet where you are storing the data in cells that you can easily be able to access those data exactly from the particular cell that you want to access. So if you've done Python data science, you use this particular idea when you are working with especially Excel. You use Python, some extensions or some imports in Python just to access particular cells or rows in Excel, right? That is what data structures is all about. We want to use a particular structure in order to manage or to organize our information. And our information could be in the form of, let's say, if we are students, we would probably be using our, let's say, our results, right? So we want a way to organize our results in a way that we can easily access our results. So if Kofi is a student of biomedical engineering, then we should be able to access Kofi's results just by specifying Kofi, right? So all these are data structures that we would come across. So first of all, let's look at the different kinds of data structures that coexist in Java. So in Java and in most other languages, these are similar data structures, right? So we simply have this array, we have a linked list, we have a stack, a queue, hashing, graph, binary search trees, a heap, and then a binary tree. So let's look at an array. Okay, so an array simply is what you know about, right? Arranging and putting some similar types together. So an example could be the age of student, and the age of student is an integer. So we are putting integers together, right? We are putting the age of students that are integers together, right? And that will be an array. A linked list is a bit different, and I would not want to talk about that because it's a little bit much more complex than an array. We have a stack. A stack is just an array, but in a stack you are going to be able to only remove values from the end of the array and add values to the end of the array. That is why we call it a stack. You keep adding to the end of the array, and when you want to remove, you keep removing from the end of the array. A queue is just the opposite of a stack. You add values to the end of the array, but you remove from the front of the array, and that makes that array a queue. So these two queue and stacks are just arrays that we are that programmers modify based on what they want the array to do. Okay. So another data structure is graph. which is similar to linked list. And we talked about not looking at linked list, so we would not look at graphs as well. We have binary search trees similar to linked lists and graphs, so we'll not look at them. We have heaps and binary trees also similar to linked lists, graphs, and binary search trees, so probably will not look at them. But let's look at the last one, that is here, hashing. So hashing is something that we've come across a lot of times, right? um I don't know, but if you've done algebra, you've done anything relating to maths from SHS, you've looked at sets. So a set is just a data structure in computer science that doesn't allow duplicates, right? So if you have two numbers like 2 and 2, you would only have one of the twos, which means one of them will be removed. So that is a set, right? And then we have other data structures within the hashing data structure. We have hash maps, right? And then we have hash sets, and that is how Java calls them, hash maps and hash sets. Hash sets is something that you've looked at. Hash maps will not be looking at them, but probably we may come across them in anything we do. Like most of the things we do, we may come across them. And in case we want to also further in learning Java, we'll probably want to know hash maps, right? So hash sets is just a data structure like an array, but it doesn't allow for duplicates, right? It doesn't allow for values of the same number to be placed within. Okay, so now let's go on. We'll be looking at only one of the data structures here, and probably that is the data structure that you guys will be looking at in class as well. So we are looking at an array here. An array is a collection of similar data elements stored at contiguous memory locations. So for an array, I think you guys have come across an array in C programming. So if you've done C programming well, you should know arrays, right? You are just storing values of the same type. An example is the first example I gave, like the student age or student scores, right? The scores of a student is just an integer, or it could just be a float, and an array could hold these same types together. And the scores of the age of a student could just be integers, so an array would just be holding all these integers together, and that is why we call it an array, right? An array could also be holding values that are ascending, right? Values that start from small to the highest. You understand what an ascending is, right? Then an array could be holding descending values, or it could just be holding random values, like no arrangement to it, right? And with an array, I think in C programming, we looked at some operations of arrays. The same way we also going to be looking at some operations of arrays when it comes to Java. So Java, we have some operations here. These operations actually are what you've been looking at. I just gave them their names here are the right names given to them, but you probably may have been seeing different names for them. So when we say traverse, what is simply we simply mean is go through the elements of an array one at a time and print them out to the user, right? So if you have an array of, let's say, 10 elements, 1 up to 10, you are simply going to be printing 1 2 3 up to 10. That is what we mean by traversing an array. Then insertion. When we talk about insertion, you are simply adding more elements to the array, right? Thereby increasing the size of the array. So that is insertion. Then when it comes to deletion, deletion is simply deletion, like delete an element from an array. And when you delete an element, you are reducing the size of the array, right? Then search. Search is when you are looking for a particular value within the array. And I think all of this that I'm looking at, like all of this, you've done them in C programming. So we are just coming to go through, or we are just revising over what we've learned in C programming, right? But in this case, we are looking at Java. So now let's explain most of the things we did in most of the things that I talked about, let's explain them with code. And we are going to be looking at basically arrays, like, and then we are going to be looking at the operations of the array, like the traverse, the insertion, the deletion, right? So let's get into that. Let me quickly open the IDE that we'll be using, and then we start looking at that. Good. So we are here now. Okay, so let me start by creating a class, and this class I'm going to be calling it learn arrays, so that we know that we are learning about arrays. So learn arrays, and that is the name of the class. Within this class, I'm going to include the main method. So I just type psvm, and then okay, I press enter, so that it generates the main method for us. Okay, so how do we create arrays in Java, right? So I'm going to show you how we create arrays in Java, and it is very similar to how we create arrays in C. So first of all, you bring the type of the array that you are creating. So you bring the type, which is, let's say, an int, and I'm showing you the C way of creating an array first. So you bring an int, and then you bring this square bracket in front of the int, and then you give the array a name. So let's say age, right? And it should be equal to the value you would want to give. So let's say we have some age of, let's say, 30, 20, 25, 25, 34, 15, 10. So this is the ages of, let's say, students, right? These are the ages of students, and this is the first way that we create arrays in Java. And this is similar to creating arrays in C as well, right? Now let's look at um, applying the operations that we talk about in the operations that we talk about applying on arrays. Let's look at how we can apply that in this case, right? So let's say for this particular array of age, we would want to print out the elements of this array one at a time to the user, right? We would want to print out these values to a user. So how do we do that? We will simply have to go through the index of this array one at a time and print the values that are at those particular indexes. So if you look at this array, how long is this array? 1, 2, 3, 4, 5, 6. So it has 6 elements. So it is 6 um, elements long, and that is the size that it will be taken in memory as well. So if memory is having 6 contiguous spaces, this array is going to occupy that 6 contiguous spaces, as you know when it comes to C. So let's say we would want to print out the element at index 2. So how do we do that? We use the age keyword, right? And then we'll use the square bracket to access the element at index 2, right? And you should remember that mostly when we are dealing with these kind of things, like when we are dealing with arrays, we start the index from 0. So index 2 is the third element in the array, which is 25. And then I'm going to store this in an integer, since the value at that place. So let's say the person who has this age is called Kwesi. And then let me end this with a semicolon. So now let me print Kwesi out. So let me use the shortcut S out, and then I'll just bring I'll write some text here. Kwesi's age is, then I include the the variable Kwesi, the integer variable Kwesi. So let's print this out and see what the output gives us. So it's running, so let's wait for it a bit. It takes time for it to run the first time, but so as you can see, Kwesi's age is 25. So this is what we are talking about, right? So we are able to access the values in the array by just specifying the index using the square brackets. Okay, so that is what we are simply doing here. What if we don't want that? We want to print out all the values in the array, right? How do we do that? We can use a for loop, we can use a while loop. We talked about the loops in Java, and the loops in C programming are just similar to the ones in Java. So if you've done C programming or any other language, you should be familiar with loops here. So let's try that out and see. So if we are dealing with, I'll go with for loop. So if we want to print out the element of the age or the values of the age out to the user, we can use a for loop. So how do we write for loops in Java? Similar to the one in C, right? So you specify int I equals 0. That is the value that you start your this thing from, and if I remember, you separate it with this semicolon. Then you specify um, the 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 condition. So whilst I is less than, let's say, the elements here are 6, right? So whilst I is less than 6, and we know that the index of age will start from 0, so it should start from 0 to 5. So whilst it is less than 6, but if it is equal to 6, we'll end it, and then we'll be incrementing our I by 1. So how do we do that? We use the I plus plus to keep incrementing our I. So if you remember this, we first check the condition, we do whatever is here, then we increment our I, then we check the condition again, do whatever is inside the for loop. So let's see, we want to print out the values of age, the age array inside this our for loop. So we'll access the index using the I variable, right? We are accessing the index using the I variable. So that is what I'm doing. I'm just accessing the indexes using the variable I, and it starts from 0 to 5, right? So there are 6 elements as well. So let's see how that what output that will bring out. So I'm running it now. So let's see. Okay, so as you can see, we started printing out from 30, then we went to 20, then we went to 25, 34, 15, and 10 is the last number in the array age, right? So you could see how we are traversing. So this particular thing that we did is what we call traverse. So we are just going through each of the elements of the array age and printing them out, right? We are just going through each of them and printing them out. Now let's look at the next operation that we can perform, which is insertion. And I talked to you about insertion earlier. I told you that insertion, you are adding to the array, and in adding to the array, we are simply increasing the size, right? And in Java or in C programming, I think in C programming as well, but in Java, let's talk about Java here. In Java, mostly when you create an array using this method, this kind of way, this C programming way, you can't add values to it. You can't insert values into this particular array. So this insertion operation cannot be performed on this particular array. But we'll look at a different way that we can actually do this. So insertion can't be performed on normal arrays in Java. So let's take note of that. Insertion can't be performed on normal arrays in Java. The same way insertion can be performed, deletion too can be performed, because the moment you are deleting, you are decreasing the size, and we are saying that for an array in Java which is created in this particular way, you can't increase or decrease the size. So deletion can be performed can't be performed on normal arrays in Java. So that is it. Now let's look at the next operation, which is search, right? Search can be performed here because we are just searching for a value. We are not modifying the array, we are not adding to it, or we are not deleting from it. So how do we search for a value? Probably we could use a for loop, right? A for loop can be one best way to search, or we could use a while loop. So let's say we are searching for a value 25, right? So let me use a while loop here. So while let's say let's see let's see what I can do here. Okay, I probably would want to use a for loop first. So let me use a for loop to make this easier for us. So the same way we did earlier, let me just copy the one we did earlier so I don't rewrite everything. So I copy this and paste it here, right? But in this case, we are not printing the values of the array. What we are going to be doing here is we are going to be adding a condition here because we want to find out whether a value of 25 exists in our array, and if it exists, then we can easily return something like tell the user, oh, 25 exists. If it doesn't, then we return it doesn't exist, right? Do you get the idea? So if let's say the array is called age, if age at index I is equal to, so how do we specify equal to? The same way in C, 25, if it is equal to 25, and I probably have to put this in opening and closing parentheses. So if it is equal to 25, what do? I'm going to print out the number. So I'll say 25 exists. I hope that is how we spell exist in the age array. Good. So 25 exists in the age array, right? Let's add a condition, right? So if this whole thing will go through the whole array, which is at the top here, if we go through that whole array at the top here and then we don't find 25, I'm going to say that okay, let me just leave it that way. Like if we don't find it, nothing will be printed out onto the screen, right? So let me run this first for you to see what goes on here. So okay, the first one was still running, so let me comment this out so that we can focus on what we are talking about, that is the um, um, searching for a value. But as you can see, the last end said 25 exists in the array, and it is true, 25 exists in the array. So 25 exists in the age array. Now let's put a value that doesn't exist, and let's see what this brings us, what the output would be. And probably, as you may be expecting, the output shouldn't be anything. It shouldn't be printing anything out onto the screen for us because 25 doesn't exist in the array, right? It doesn't exist, and that is how we search for values in an array, right? And we talked about 4 operations here. 2 of the operations can be performed on this particular array, right? And 2 can't be performed, the insertion and the deletion, right? And the 2 that can be performed are not modifying our array in any way. The other 2 that can be performed are modifying the array, and that is why we can't do that here. And that is it. Probably I knew the size of the array and I was using the 6. Let me make mention of that here. I was using the 6. But what if you don't know the size of the array? Or what if, let's say, I change the size by adding, let's say, a value 14? So there is a way of finding a size of an array in Java, the same way we have in C. So in Java, you use the array and you specify this particular property, length. There is a property called length on an array, so it also does the same thing. That's the same thing as specifying the. So in this case, we are not specifying, we are not hard coding the value here, but we are putting the value based on the number of elements here. So the computer should be able to tell us the total age, and then that is what we are going to use for our condition. So there are 7 elements here, right? So we will start from 0 to 6, and that is what we are going to be doing here, right? Now there is another way of declaring arrays in Java, and it is still a static array. We are not going to be able to insert or delete into this array, but we are only able to be able to traverse or search through the array, right? So that way, let me use int score. So I'll name this a score, and I'm just going to be using integers here. So 35, 74, 90, 87, 20, 98, 99. And please take note, as you could see, I'm separating this with comma. This is the same thing as what I did earlier, so I'm going to be changing it. And look at how I'm going to, I just need these values inside, so I'll keep them somewhere else, and I'll comment this out. And what I'm going to do is I'm going to use the new keyword. So we use new score, and you specify the number of elements that you would want to put here, which is how many elements? 1, 2, 3, 4, 5, 6, 7 elements, right? New let me see, is it new score or new array? Let me check that out. New array. Okay. Let me see. Okay, it seems I'm forgetting the way we can do this, but let me quickly check it out. I think let me search on the internet. So Google should be your friend anytime you don't remember something. So using new keyword for an array in Java. So how do we do that? Let me search for a better way. Okay. W3 schools. Okay, so give me some few seconds and let's just look at this, how we can do this. And let's see, Java arrays. So these are arrays. Let me check that out quickly. And how do we do that? Okay. Still can't find it. Okay, so if I can't find it, probably we'll look at it another time. But I remember there's a way of using the new keyword, and then you can just do the same thing here as well. Like that is how you could do you could create arrays that are static. Now let's look at creating arrays that are dynamic, right? Let's look at creating an array that is dynamic. So how do we do that? Now let me just clear out everything here, because we don't need them again. So I'll clear them out. Now we want to create arrays that are dynamic. So how do we do that? We use a class called array list, and this is simply going to be an array, but it simply allows us to be able to add more elements to the array and then also delete elements from the array, as well as doing the searching, and then as well as doing the traversing. So the four methods or the four operations that are performed on arrays can be performed on this array list without any problem, right? So now let's look at how we can do that. First, in order to use an array list, it's a class. So because it's a class, you have to import it. So it is found in the array java.util class. So you specify java.util.array list, and that is it. You've just specified, or you've just imported an array list class. And as I said, what this class lets you do is it allows you to be able to traverse, that is to go through each of the elements of the array and print them out. It allows you to insert, and that makes the array dynamic. The size can increase, right? And then it also allows you to delete, also making it dynamic. You can decrease the size by deleting elements, and then you can also search for an element. So let's look at how that can be done here. So first we need to create an array list. So how do we create that? We write the keyword array list, just as we do for normal objects that we create in Java. We use the array list object or class. Then I'll use obj to specify that this is an object. And mostly when you are specifying array list, you would be using this um, um, how do you angle bracket to specify the type of stuff that will be going into this array list. So the type of things here will be an integer, right? Because we are going to be looking at the age of students. So let me write here age. Then I'll use the new keyword, and then I'll use array list again. So that is how we do it, but you could see that this int is being underlined, and one way to correct that is I think using an integer instead. So there are two different things, right? Instead of using int, use an integer. It's the same thing. It's the same integer, but because this is a class, we can't be passing it a normal primitive type like int. We pass it a non-primitive type like an integer. And if you get into Java a bit, if you try to learn some things on your own, you understand what a primitive and non-primitive types do, or what they mean, right? So what this simply mean is that I'm creating an array that will be that will be full of integers. So I can't add anything that is not an integer, right? So let's first see how we can add to this array. So we can add values to this array by specifying this add method on the array. So we have a method called add, right? So how do we specify, how do we add a value? We pass in a value that we want to add, but we've not specified whether we are passing this value to the age. So we write age, then we bring a dot, and then we use this method add on it. So we use the dot operator to add the value to age, the age array, right? So you specify first the age, then you bring the dot operator, then you add the method add, right? Then you specify the value you would want to add. Since it's an integer, make sure this place is always an integer. So let's now do another add. So we are adding ages. So let's say 25 here as well. Then let's say another age 14, then another age, and 35, then probably the last one, age dot add 30. Let me add another last one, age dot add 20. So 20, something of this. So you could see that I can keep adding values to this array, and it makes it dynamic. As I continue to add the values, the size also changes, right? The size also changes. I can print this array out for you to see if only it works. So age, let me see if I can actually print this age out. Let me see. I hope it prints out age for me. Okay, good. So it's printing out the age for me. So as you can see, I added in a particular order, and that is the same thing it is doing here, right? It's giving it in that particular order. I kept adding to it. So let me say I add another value to this particular age array. Let's say 15. I think 15 doesn't exist there, so let me add 15, right? And let me print this value out again for you to see. So after adding 15, how would my array look like now? So let's wait for it. It's loading up, and as you can see, yes, so first there were only like 6 values. I added 15. Now there are 7 values existing in the array, and that tells you why would prefer using an array list as compared to an array, because in this case we are able to insert values. So adding a value is simply like inserting a value. So we've looked at 4 methods, right? We looked at the traverse, we looked at the insertion. We are supposed to look at the insertion. We are going to be looking at all of them here again on this particular array list. So deletion, then the last one being search, right? So insertion is what we just looked at, right? Insertion is what we just looked at. So you can add values. So insertion, let me place insertion here. So you can add values to an array list by just using the add method, right, on the array, on the particular array that you want to add a value to. Then what if we want to traverse or want to print out the elements of each of this array? How do we do that? Simply, we can use a for loop. So as we did earlier, int I equals 0, then I is less than the in this case we don't remember the size of an array, but you remember when I was using a normal array, I said that you can specify a length property on this particular normal array. But in the case of an array list, you don't specify a length property, you rather specify a size property. So age dot size, and that gives the size of the array, all the elements in the array, the size of all the elements that are contained within that particular array. Now since we are doing traversing, we're supposed to be printing out the values in this particular array. So how do we do that? We use the age and then the same index keyword, and you could see that this won't work, right? So in uh, 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 in an array list, we don't just use the same way that we did with the first case, the static array. We use a method called get, and this method gets the value at the particular index that we want, right? And you can see that it is working now. So let's try and print out the values of this particular array and see what we get as the output. So let's wait for it. It's loading up. Good. So as you can see, it started from 10 and then 25, 14, 35, 30, 20, and then 15, just as it is in the second array, that was printed out. So that is traversing an array, right? That is sort of traversing an array. Insertion is what we talked about. You use the method add. And then what of deletion? So let's say we want to delete. So let me comment this out since we are coming to do something else. We want to delete an element out of the array. So if we would want to delete, we use the keyword remove, right? We use the keyword. So let's say on age, we want to remove the value. Let's say we want to remove the value 25. Sorry, you don't specify the value 20. Since the value 25 is at the second index, we put 1 there. So in remove takes an index, right? It takes the index of the value you want to remove. Now I'll print out my array age for you to see that truly this value has been removed. So let me do that. Let me print that out for you to see. And I believe this video is getting longer, but it is very important for you to understand this particular concept. So as you could see, earlier on there was 25 at index 1. Now it is removed, and the value at index 1 is 14 now, right? So you could see what I mean by removing, right? So you can, in this case, the value of the array or the length of the array keeps changing anytime you use this remove keyword or this remove method, right? So let me try that again by removing another value at a particular index. So let me remove from index, let's say 2. So I'm removing from index 2, that will be 35, right? From this array, the last array that was printed out, the index 2 is 35. So let's see what will be printing out. So we can expect to be printing out 10, 14, 30, 20, and 15, excluding the 35. And that is what we should be expecting. So now let's run this and see what the output would be. So I'm running it now, and voila, as you can see, the 35 has been removed, and we have 10, 14, 30, 20, and 15. So the values keep changing, right? So that is what we mean by what deletion. Now let me comment this out, and let's look at the last one, which is search. So how do you search an array list? So for searching for an array, a value in an array list, we can use a for loop as we did earlier, but there is even a better way of doing it. They've given us a method called let's see, okay, so we should rather use a for loop. So we can use a for loop to search for a value, just as we did earlier. So the length of this array is age.size. And please, I didn't learn this, I just don't know this. I just have to search for it whenever I feel like I want to do something with an array, like let's say an array list. If you would want to search for a value in an array list, you should search it on the internet, and then it gives you options like different ways of searching for a value in an array list. If you want to get the size of an array list, you can search for it on Google, and you are totally right when you do that. It's just a learning process, right? So you keep learning when you keep searching for things, when you keep coming across things, and then you search for the solution, and then you keep the solution in mind, right? So how do we do a search for a value? So if using the same idea, so if um, age dot get, so we get a value as a particular index. If that value is equal to, let's say, Let's see the values we have 25, 14. I'm looking at this particular second array because I commented these ones out, so they won't be printed out. So I have this. So let's say if something is 35, so 35, which is at index 0, 1, 2, and 3, so it is at index 3. I'll print out um 35 exists in the age array. Okay, cool. So let's do that. Let's print that out and see what to give us. So let's wait for it. Yeah, so 35 exists in the age array, and if I specify a age that doesn't exist, you could see that nothing will be printed out. Good, so nothing was printed out. It was only these first arrays that were printed out. Then it came here and ran this for loop and saw that there was nothing like age being equal to 36, or there was no value in age, the age array that was 36, so it didn't print anything out, right? So that was a simple arrays. Like, we've just dealt with data structures, one of the important data structures in Java, which is an array, right? And we have different ways of representing arrays in Java. We can just use the normal array that we looked at in C, and we can also use the array object, which is a class in Java that Java provides for us. And the importance of the array object is that it allows us to do the four operations of an array, that is traversing, insertion, deletion, and searching for a value. For the case of a normal array, you can only traverse and search. You can't insert and delete. And the reason is that for an array, it is not dynamic. You can't change the size of an array so far as it is created. But for an array list object, you can keep changing the size since it's a class, right? So you can keep changing the size. And for an array list, it gives us even important methods like the add method, the get method, the remove method, and so on. It gives us a lot of methods that we can work with, and that makes it even easier to work with an array list, right? So that brings us to the end of our tutorial for today, and thank you for staying, and hope you will subscribe to this channel, and we'll be bringing you more next time. Bye.